Alright, this video is going to demonstrate BLISS, which stands for Biometric Labeler and Image Segmentation Sandbox, which is a program that's useful for, as the name implies, labeling images specifically for biometrics research. So it's only been tested in Linux, so I would try Ubuntu 14 or whatever the latest long-term release is. So to start it, you're going to use the command line. So in this case, Control-Alt-T brings that up. Now I have it on the desktop here, so navigate to there and into the folder, BLISS version 0.1. So to run it, you type Python bliss.pyw. Okay. So first thing is you want to import your pictures. Now the thing about this is, before you start processing something in BLISS, you want to make sure you've got your pictures where you want them in your directory, because once you label them, if you move them around within the subdirectory, it'll mess up the labels, since they're stored in an external file and they're not in any way bound to your pictures. So you want to load directory. Now I've got a little test directory I created under pictures webcam. We'll use pictures dataset 0. So hit open. So that imported them. So let me expand the window a bit. Let's full screen it. Okay, now they appear to have been imported kind of in reverse order, although the order does not seem to be reliable, but that's beside the point. Okay, so quick overview. Now a lot of images are really large, so you're going to want to take note of the zoom feature. So zoom 50% or whatever, but these are low resolution, so it doesn't matter here. Just go to 100%. So once you import your images, you're going to look through them, and you'll notice that, oh, this is not a good example. One of these is supposed to be flipped, but it isn't. So as you go through, if you see a picture that is rotated incorrectly, there's a feature in here under transform. You can rotate clockwise or counterclockwise, and it'll immediately save that back to and overwrite the existing picture file. So just beware. So to actually get faces out of a data set, you're going to want to select all the items that you're interested in having segmenting, and you can obviously omit any ones that you want by using Control, like this, or you can just segment one if you want, but let's just do them all. So segment face eyes. Now it'll give you this input dialog, which asks you what's the minimum size of face you want to be able to find, from 0 to 1, where it's percentage of the width of the image. Now the default is, of course, 5%. I'm just going to leave it at that, so leave it blank. And there it goes. So as you can see, it found faces in all sorts of places, including ones that are false detections. Now let's look at one that was fairly non-problematic. Okay, this one. So you'll see that there are 3 regions of interest that were created, one for each eye and one for the face region. It also attempts to find the centers of the eyes. Now if it happens to get the eye centers wrong, as it does in this image here, you can correct that. So I'm going to zoom in 200%. By simply put the cursor where the mouse where you want it, and double click on the right mouse button, and it will move the closest point that it finds to where you clicked. So there we go. And let me reset my zoom back to 100. Now when you have false positives, like in this case, there's a couple things you can do. If they're very small, such as let's see, This image has some that are, yeah, like this one is really small. Sometimes you'll get really tiny ones, especially in really big images. One thing you can do to save yourself time is you can resegment just that image and maybe increase the minimum detection size to, say, maybe 20% of image width. And there, that took care of them. Now, in some cases, when your false positive is roughly the same size as your actual detection, you're going to have to manually edit the regions of interest, such as here. So what you do is you'll select them over in this list, and they'll turn green once depending on what you have selected. So whichever ones are selected are green. And then you can hit the delete key on your keyboard, and there they go. Okay, so looking at these, this is reasonably acceptable, except for here. Since the face is pretty much taking up the entire image, the cascade didn't detect it. So what you can do in this case is you have to manually add the regions of interest for the eyes, since the eyes are really the only thing that's important in terms of segmenting out and generating derivative data sets. So to select a region, you simply left click and drag and then release, and there, now you have a region of interest. Do the same thing over here, and now you're going to have to add a label to it because it doesn't know what it is that you've boxed in. It could be anything. It could be a cat, soda can, face, etc. So you have to add label, and this, you have to say that this is an eye. Now what it'll do is it'll search through all the different labels it already has, and it finds something that's an eye. It'll look for properties that are of an eye and automatically initialize it, but you have to enter the values. So this is the left eye, although technically it's the right eye, but we'll say left because it's left in the image. And then to get the center, one thing you can do is if you double click with the right mouse here, not only does it potentially correct any points that are there, it also copies to the clipboard the coordinates of that point. So then you can Control V to paste it in, and then click Save, and then you'll see that it now denotes where the center of the eye is. And then repeat the same process for the other eye, except that just moved it. I have to add label first. See, I'm already forgetting. Okay, so add label. This is an eye, right? It's the right eye. And let's see if we have our coordinates. Okay. Save. And there we go. Okay, so now that everything's labeled properly, let's double check that. It's good enough for the demo. Okay, so now we want a derivative data set. So if you go to export, you can export a face data set, and it asks you how much space you want around the face. Now all this is based on the distance between the eyes. I'm going to leave it at the default of 0.23, but if you want more or less of the face, you can obviously give it a value. So there it goes. So what it did is if you go into the directory, you'll see it created a new subdirectory. It's the name of your root directory plus face is on the end. And there you see we've got just the cropped face regions. Some of them are pretty low resolution. It resizes them to 512 by 512 pixels by default. There's currently no setting to change that. You have to go into the code. I may add some feature like that later. Okay, now the other thing it can do is generate a periocular data set, which is the eye region. So let's export periocular data set. Leave same default. Alright. So here we go. Now for each image there should be a left and a right eye. So it has two copies with left and right appended to the file name. And so there we have it. Periocular data set. Now one thing that's really important is that you must save all your work. Otherwise all the labels will be lost. It does not prompt you currently when you quit whether or not for save or not. So if you forget you lose a lot of work. So always do save, and it'll ask you for a name, and I'm just going to say or we'll just call it labels.json, You can always save different versions if you decide to segment it some other way and you don't want to interfere with what you've already done. And then of course you can close out. Now if you look inside the directory, let's see under pictures, you'll notice there's a labels.json, and here's what it looks like internally. Basically has, each picture's path, regions of interest you defined, and the labels and properties of those labels. You will not need to edit this normally, but you can if you want. Now if you'd like to load that up again, you'll run the program as before, and you will go to File. Instead of Load Directory, you'll want to Load JSON, and of course navigate back to your directory, and then click on the JSON file, and there all your work that you did is still there, saved there. You can go back to where you left off. So that's basically the gist of it. So that's BLISS in its current iteration, version 0.1. Hope we find it useful.